Hi, this is Math 1115, remote delivery for April 27th, 2020, and this is part 1 of 2. We're going to be talking about section 7.1 from your book, and this is... So today we're going to be talking about solving quadratic equations by factoring. So if you have a, b, and c, which are constants, and a is not equal to 0, then this equation is called the general quadratic equation in x. Notice that I moved things around so it is equal to 0. The coefficient of x squared is a, the coefficient of x is b, and c is the constant. This function is also known as a quadratic function. Quadratic meaning degree 2. Any equation that can be simplified and then written in this form is a quadratic equation in one unknown. Often you will have to do that to get it into this form. And as a hint, I'm going to tell you it is usually easier to have an integer coefficient and a being bigger than 0 in a quadratic equation. This can be done by multiplying each term by the least common denominator if they're fractions, and to change the sign, you multiply all the terms by a -1 on both sides of the equation. Let's look at some examples of that. These are quadratic equations because it is exactly of that form. This is also a quadratic equation, but this time the coefficient of the x term is 0. This time the coefficient of the constant term itself, is 0. Here, the constants in the equation may include little expressions. So here, m-1 is a constant here, or m-3 rather, and m and 7. Here, this is also a quadratic equation because you can rearrange it so it looks like 3x squared minus 2x equal to 0. This is also a quadratic equation because if you were to FOIL this, take x plus 1 times x plus 1, you would get this. So those are all examples of quadratic equations. These are not quadratic equations because there's no x squared term. You can't have in a quadratic equation the highest power of x has to be squared. Here it is x cubed. And here the x squared term will drop out, and so it is not a quadratic equation. So a solution of an equation is all numbers, then often they're called roots, which can be substituted into an equation to give equality. There are 2 roots for a quadratic equation. At times, these roots are equal, and so that means only one number will show up as a solution. And also the roots can contain imaginary numbers that we talked about. If this happens, all we need to do is to say that there are no real roots. When you study your electronics technology, you will have other reasons to do this, but that's our simplification right now. So, for example, this quadratic equation has roots this and this, because if I take these values, 1/3 and 2, and substitute them in, I get 0. So the left-hand side, when I substitute these values in, is equal to the right-hand side. This quadratic equation has exactly one root. It is x equal to 1/2, but that's called a double root because when we put x equal to 1/2 in, we get the solution. And here, if I have x squared plus 9, the roots are not going to exist as real numbers because if I take any real number and square it, I will get a positive number. I add a positive number 9, I have a positive number, not 0. So here there are no real roots. To solve these then, what we're going to do is get them in the standard form. Then we're going to use what is called the zero product property. And that says if I have a whole bunch of numbers multiplied together equal to 0, then at least one of the numbers has to be 0. So what we do is we get it in the form that we want to have, like this, have it set equal to 0, and then we factor if we can. You can't always do this. You set each factor equal to 0, and you solve the linear equations, and these are the roots, and you can always check. So let's look at this one. This is in the form that we want it, so we factor. Now we have two expressions, this one and this one, that are being multiplied together equal to 0. So either this one equals 0 that tells us x is 4, or this one equals 0 that tells us that x is equal to minus 3. Now we can check these back in the original equation, and we see they both work. When I put those values in the left-hand side, I get the right-hand side. So both roots satisfy the original equation. Here's a problem where it is not in the form we want it, so we have to rearrange it. We're going to move this 4x to the other side. Now we have it set equal to 0. And then we're going to factor this left-hand side. Now when we factor this, we will get x minus 2 times x minus 2, which is the same thing as x minus 2 whole squared. So either x minus 2 equals 0 or x minus 2 equals 0. Either time we will get x is equal to 2. If we check, that does satisfy the original equation, and we have our solution. Now here are examples where certain things are missing. Here my linear term is missing. But what I can do is I can factor out a 3, and I in fact can divide both sides by the 3. 0 divided by 3 is 0. So this ends up being just x squared minus 4 is equal to 0. This is a difference of perfect squares. This is x minus 2 times x plus 2 is equal to 0. I set each of those in turn equal to 0, and I get x is 2, and x can be minus 2. Now this problem, we have a constant that's equal to 0. So what we're going to do is factor an x out of this. Or first of all, we're going to divide both sides by 3. And when we divide 0 by 3, we still have 0. So we have this expression. And now we're going to factor out the common factor, which is x times x minus 4 is equal to 0. You can never divide through by the x because you would lose a root. So you see I have two things being multiplied together. X times the factor x minus 4 is equal to 0. So x is either equal to 0 or x is equal to 4. Word problems still exist. You can slow this down and look at the word problem if you want, but they're basically saying this is the equation we want, but they want you to solve this for p equal to 15. So I put 15 where the p is, and I'm going to solve for q. So I start with this. Now this is not in the form that I need it to be in, so I'm going to move the 15 to the other side. Now I have this is equal to 0. Now I'm going to factor both sides. And again, you have to be good at factoring to do this, but we do this is equal to 0, and then that means that either this factor is equal to 0, in which case x is 5 over 2 or 2.5, or this side is equal to 0, which means that q is minus 3. Now it turns out that even though the math is good, minus 3 does not make sense for a flow rate, and so we will reject that answer as not making physical sense. So there's only one solution. It is q equals 5 halves, or 2.5. Life is a word problem, so you have to be careful with word problems. It also is possible for quadratics to arrive in other kinds of problems. Here we're solving a problem that we called a fraction problem. You might remember the way we solved this was multiplying all the way through by the least common denominator, which is x times x plus 2. So x times x plus 2 times this, times this, times this. And then I have to simplify. Here the x will cancel one with another. Here I have to expand it. I get 3x squared plus 6x, and over here the x plus 2 will cancel one with another. So I have this expression when I simplify. This is not in the form that I want it. I have to move this to the other side to have it equal to 0, so I do that. And now I have something finally in standard form. Now I have to factor this. I get 3x plus 2 and x plus 1. I set the first factor equal to 0 and get x is minus 2/3. I get the second factor equal to 0 and I get x is minus 1. Both of these check. Now you are cautioned, even though that didn't happen here, you have to remember that if either value or both gives division by 0, the root is extraneous and is not part of the solution. Here's another word problem. You have a truck traveling 60 miles from a sawmill to a lumber camp and then back in 7 hours' time. The truck averages 5 miles an hour less on the return trip than on the trip. Find its average speed. Well, you know distance is equal to rate times time, or velocity times time, but that means time is equal to distance divided by v. And what you want to do is find its average speed. And so what we're going to do is we're going to set up, this is the time to the camp, This is the time from the camp, and the total time was 7. So we're going to solve this by multiplying all the way through by v times v minus 5. Now when we do that, we get this, and then we have to simplify, move things around to get it in the form we want. And now we'll have to factor, because now we have it equal to 0. We factor, we get this. And so we say either 7v minus 15 is equal to 0. That means v is equal to 15 over 7. Or v minus 20 is equal to 0. That means v is equal to 20. Now the value, this one, cannot be a solution because the return speed was 5 miles per hour less, and that would make it negative. So the only solution we have is v equal 20. That means the return speed was 15 miles per hour. That was what we were to find. And the trip to the camp took 3 hours, and the return took 4 hours, which shows that the solution indeed does change. You should try some problems just to test your understanding. Here are 3, a couple of practice exercises, and a word problem. This word problem deals with projectile motion. You might remember the very first class we ever had, I told you we would solve this problem. Today, we're solving this problem about projectile motion. Hit pause, and let's see how you do. Let's see how you did. Here were the answers to 1 and 2, and this is the answer to number 44. We factor out the minus 16t, and that tells us that minus 16 is not going to be equal to 0, but t could be 0, or t could be 20 seconds. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. I will see you in